In this video, I want to look at another way to conceptualize these now familiar logical symbols, A, B, C, and so on. And I also want to look at the interesting ways that they can interact with each other, yea, even overlap. What do I mean by that? For example, it is not logically demanded that A be completely different than B, or that all things within A are not within B. Meaning, it's not demanded logically that A be absolutely mutually exclusive from B. B, for example, could contain all of A. B could contain only some of A. It's also possible that B contains none of A. The inverse is true from A's point of view. A could include none of B, only some of B, or all of B. These symbols simply represent whatever clause within an argument that they are being assigned. Now, let's look at a more concrete example to more fully appreciate the ways that these two stand-in symbols, what different ways that they can relate and engage with one another. Let's say I'm in an apple orchard and I see this funny looking tree, this magenta colored producing organism, and on this tree we have 4 funny looking apples that happen to share the exact same color with the tree. And a passerby says, "Hey, these 3 apples," and I'm going to label them according to the ones that this person is indicating, 1, 2, 3. This person walks by and says, "Those 3 apples look good to eat." We are going to now define A as the sum of his sentence. These 3 apples look good to eat. 1, 2, 3. This is the full. Let's make sure that 3 is a little bit more legible. A includes the full extent of this sentence. Now note that it's not saying that these 4 apples look good to eat, or it doesn't even have anything to say about the tree that it's on or its immediate ecological context. It is simply saying A is simply being defined by these 3 apples, these particular apples look good to eat. Now, let's say that as I'm viewing this particular apple tree, another person walks by at the same time and says that this entire tree has fruit that look good to eat. So we're going to define B as this entire tree. We're going to add all 4 apples. And we will name this one as well, number 4. This person says this entire tree has apples, all of the apples. Let's say there's only 4. That's sorry for those not being super legible. Let's say there's only 4, or at least there's 4 visible ones, and these 4 visible apples were the ones, were the population that the 2 passerbys were referencing to. Person 2 walks by and says that this entire tree has 4 apples that look good to eat. Now, note the interesting differences and similarities among these 2 categories. A is defined by these 3 apples being good to eat. 1, 2, 3, 1, 2, 3. That is A. All things that are not this are not A. B is saying that this tree, these 3 apples included, plus the apple here, and plus anything else that may be good to eat, all of this looks good to eat. So we see that B includes the definition of A. Now, the argument is taken further. The argument is saying, at least implicitly, that it's not just these three apples, it's in fact this apple and other elements within the tree that are being addressed in terms of their future pleasant taste experience. But we see here that A and B don't have to be contrasting. They don't have to be mutually exclusive. They can overlap. They can agree with one another. And in this case, we see that B does include the full definition of A. We have overlap here. In this particular case, B extends the point A is making, and it's simply saying there's more to enjoy than simply these three apples. Now, we could visualize this by drawing a Venn diagram, and let's go ahead and do that. So let's create A. A is going to be represented by this circle. This is A. Now, B, we're going to use color yellow. B is saying that these three apples plus more are going to be good to eat. So in this case, B, we can visualize it this way. B is saying these three apples, if we're bringing this into here, these three apples are good to eat. It's also saying there's more things that are good to eat. There's another apple. There might be a way to distill, tasteful artifacts from the leaves, or maybe there's a way to soak the bark in such a way that you create syrup, or however else someone can extract things that taste good to them from this particular tree. And so we see here that even though A and B are distinct, they are discrete from one another, they also happen to overlap in a meaningful way.